Hello friends, welcome to the channel NetKingIT. In this video, we will go through the AWS networking terminology in short description and its position in the AWS cloud infra. So these are the major networking services that usually use on the AWS. These are the core networking services. So we will discuss one by one. The first two are the region and availability zone. So AWS region is a physical location in the world where Amazon Web Services clusters its data centers. So each region is geographically distinct area containing a minimum of 3 isolated and physically separate availability zones. So these availability zones are nothing but the data centers. Let me quickly show you how many regions and availability zones AWS Amazon have till today. So if I click on this website, this is the AWS Amazon website where we can find this information. So till today, Amazon has around 39 geographic regions, and within this region, they have around 123 availability zones. So far, this is the count. Let me show you how the AWS cloud span across the world. So these are the regions where AWS have their footprint. Let me click on this US East Northern Virginia. If you see here, it has around 6 availability zones. So this region contained around 6 data centers. Similarly, if I click on one of these other region belongs to Asia Pacific. This is a Asia Pacific Mumbai region. So it contained around 3 availability zones, means the Mumbai region contained 3 data centers. So we can consider one region equal to one country, but this is not necessary. One country can have multiple regions. Like in India, there are 2 regions. One is Asia Pacific Mumbai and other one is Asia Pacific Hyderabad. So this one also contain 3 data centers. Okay, I hope you understand till now. Let's move on to other component. Let's have a quick look on the AWS availability zone. AZs are physically separated data centers within an AWS region designed for high availability and fault tolerance. So each AZ has independent power, networking and cooling with at least 3 AZs per region, as we discussed. They are interconnected via low latency, high bandwidth networking, providing redundancy against failure like disaster or power outages. It is up to us whether we use all 3 AZs or just a few of them. So generally, we opt for 2 AZs to achieve high availability, resiliency and fault tolerance. So for example, I can create few servers in AZ1 and few servers in AZ2. Those AZs are interconnected with the high bandwidth and that will be managed by Amazon. Okay. So in case of one AZ goes down, in that case, we can have these servers available from the other AZ. That's why we use multiple AZs in one region. Next topic is Virtual Private Cloud, VPC. So VPC is a logically isolated private network within the AWS cloud dedicated to your account. It enables you to define your own IP addresses, subnets, route tables, and gateways, etc. It is allowing you to launch AWS resources like EC2 instances. So EC2 instances, nothing but the servers or database that we created or we launched over the EC2. So if you see in this diagram, the orange box is the region, the blue box is the AZs, and the green box is the VPC. So just for the simplicity, I have shown you here single VPC box. We can create multiple VPCs within the region. Okay, for simplicity, I just shown you single VPC here. Also, one region contain at least 3 AZs. For simplicity, I have shown you just 2 AZs. It's up to us that we can utilize just a 2 single or the all 3 AZs. Okay. CIDR block. So it's a classless interdomain routing is an IP address range that you must specify when creating a virtual private cloud VPC. So I have mentioned here, if you see, this is the CIDR. In this case, in this example, 10.10.0.0/16. Later on, when we are going to create the subnet in AZ, then we divide this network into subnets. So multiple subnets we can divide according to our requirement and we can assign within the AZs. This block defines the total range of private IP addresses available for your resources. As I said, we create multiple subnets and we can assign as per our requirement. Like few subnets we assign to dev environment, some subnets we assign to production environment, some subnet we can assign to the test environment. Likewise, when you create VPC, you assign its primary IP CIDR block. In this example, it is 10.10.0.0/16. This block cannot be changed or removed later, though you can add or remove secondary blocks if you think primary CIDR block is fully utilized and need more IP subnets. So while we are creating VPC, we have to think twice while assigning the CIDR, because once we assign this CIDR, that cannot be removed or alter. So, but there is one option that we can assign secondary CIDR and it can be used similar as the primary CIDR, and the secondary CIDR we can remove or change as per a requirement, but the primary one we cannot remove. Subnets. The VPC CIDR block is divided into smaller CIDR blocks for subnets, which are deployed across different availability zones. For high availability, subnet CIDR blocks cannot overlap within the same VPC. So in this example, if you see, this is the CIDR block and we have divided into few subnets that you can see here. Subnet 1 is 10.10.1.0/24. Subnet 2 10.10.3.0/24 in AZ1. Similarly in AZ2. So these subnets we can create and those are always reside or always from the CIDR block 10.10.0.0/16, and these subnets should not be overlapped. And while we are creating subnet, it will not accept if the subnets are getting overlapped. There are two types of subnets: public subnet and private subnet. Public subnet has a direct route to an internet gateway in its route table. Resources within a public subnet can have a public IP addresses and communicate directly with the internet. So if we refer this diagram, one subnet should be associated with one route table. Okay, let's say we have the route table here, and if this route table has default route towards the internet gateway, if there is a default route towards internet gateway and this subnet is associated with this route table, then we call this subnet as a public subnet. Hope you understand. So basically, whatever the resources we build in this public subnet, let's say this is the Windows server, then this server will get the public IP address and this server can access the internet through this internet gateway. Also, it can be accessible from internet, this server. So basically, the public subnet gets the internet access due due to the routing table where we have the default route entry towards the internet gateway. Hence, we call this subnet as a public subnet. So in short, public subnet has the default route towards internet gateway. Private subnet does not have direct route to an internet gateway. So if there is a table, routing table for the private subnet, it can be the separate routing table for private subnet. And generally we call the private subnet route table because it don't have the routing entry for the internet gateway. That's why we call it private subnet. And the resources inside the private subnet will not have access to the internet because there is no route to go out through the internet gateway. Let's have a look about the routing table in the next slide so we can get the more idea on it. Route table. Route table is a set of rules called routes that determines where network traffic from your subnet or gateway is directed. So by default, there is a main route table. This is the default route table that is automatically created with your VPC. Any subnet that is not explicitly associated with another custom route table will implicitly use the main route table. So basically, as I said, subnet should be associated to any one route table. Okay, if for example, if we have the additional route table, since custom route table we can create, but if the subnet is not associated to any of the route table, then it will by default use the main route table. Okay. If there is no association to any of the route table, then the subnet will use the main route table. Okay. Custom route table. Let me show you in the next slide. So if you see, this is the good example of the custom route table. You can create additional route tables to have more granular control over the network paths for specific subnets. This is useful for creating public subnets with the route to an internet gateway and private subnet with a route to a NAT gateway for outbound internet access. So what does it mean? If you see in this diagram, there is two route tables, public route table and private route table. So this is the custom route tables. Subnet should be associated with at least one route table. So one subnet cannot be associated with two route tables. Okay, the subnet, any subnet can be associated with any one route table. Okay, so one route table can associate multiple subnet. Okay, but one subnet can be associated with any one route table. Let me explain you. So as I have shown you here, the private subnet is associated with this route table. But let's say I don't have association with this route table, then I can use this route table for this subnet. Okay, so my public route table can have multiple subnet association. Okay, but the same subnet cannot be associated with the other route table. Okay, so one subnet always will be the associated with any one route table. This is not possible. Okay, in this example, public subnet is associated with this route table, PUB route. This is a public route table. So if you see why we call it public subnet, because the public route table has the default entry to reach the internet gateway. So whatever the resources reside inside this public subnet can have access to the internet. That's why we call it public subnet. In case of private subnet, there is no direct connection or there is no default route or any route towards the internet gateway. Hence, this is a private subnet. So private subnet resources will not have access to the internet. So there is a way that private subnet resources can access the internet through NAT gateway. Hence, you can see majorly the private subnet route table has the default route towards the NAT gateway to reach the internet. So if suppose any one machine want to access the internet, then from the private subnet, they need to have the route table entry towards the NAT gateway. So onwards, I will just show you connected this subnet connected to the NAT gateway. Basically, there is a route table which has the default route towards the internet gateway. Okay, hence we call it public subnet. Okay, onwards, I am not going to show public route table in the diagram to keep it very simple. Okay, so currently I am showing here the direct connection with public subnet to the internet gateway, but just consider there is a public route table which has the default route towards the internet gateway. Hence, this is the public subnet. Okay. Next, Elastic Compute Cloud, EC2. It provides secure, resizable virtual servers instances in the AWS cloud, allowing for instant provisioning of computing capacity. Users can select from various OS types like Linux, Windows, Mac OS, instance size, and CPU memory configurations to host applications and databases, etc. If you see in this diagram, we can create multiple EC2 instances within a subnet, and on this instance we can run Windows or Mac OS servers. If that server within a public subnet, then that server get assigned the public IP address, and that server can have the access to the internet. Similarly, the server which reside into private subnet, that will have the private IP address, that will have no public IP address and will not access internet. I hope so far you understand the position of the each component. The outer side, the orange box is nothing but the region. Inside region, we have the green box, which is VPC. Within VPC, we have AZ1 and AZ2, two data centers. Inside AZ, we have the public subnets and private subnet. And inside the subnet, we have EC2 instances wherever actual servers VM runs. In this video, we have completed the first part where we discuss about 7 networking services, or we can say terminologies, that is region, availability zone, VPC, CIDR, subnets, routing table, and EC2. In next video, we will discuss about rest of the AWS networking terminologies. I hope you found this video informative, and thanks for watching it.